All right, let's just jump right in. Have you ever been there? You know, a massive concert ticket sale goes live, or it's the biggest shopping day of the year, and bam, the website you need most just gives up. It feels like the entire internet is trying to squeeze through one tiny little door. So how do the giants, the Amazons or the Googles, handle millions of users every single second without even breaking a sweat? Well, today, we're going to pull back the curtain on the invisible heroes that keep our digital world running.
It is one of the most frustrating experiences, isn't it? You've got your credit card out, you're smashing that refresh button, and then you get that dreaded error page. But you know what? This isn't just bad luck. It's a fundamental engineering problem. And thankfully, it's a problem with a really, really elegant solution.
So the heart of the issue is something engineers call a single point of failure. Just picture it. All that traffic, every single click, every page load is just hammering on one single server. Now, no matter how powerful that server is, it has a limit. And once it hits that limit, it just gets overwhelmed and it crashes. For a business, that means lost sales, unhappy customers, and for you, well, it means no concert tickets.
Okay, so if one server isn't going to cut it, the obvious answer is to use many servers. But that just creates a whole new problem, right? How do you direct all that traffic to all of those servers intelligently? Well, you need a director. You need a traffic cop standing right out in front of your servers, making sure no single one of them gets overloaded. And in the tech world, we call this a load balancer.
It's such a simple idea, but it's incredibly powerful. The load balancer becomes the one and only front door for all the traffic coming in. Its entire job is to greet every request and then quickly pass it off to a server in the back that's ready to work. This simple act of distribution is the absolute key to keeping a site online under pressure, what we call high availability, and it lets it grow to handle huge demand, which is scalability.
The whole process is really just 4 simple steps. First, your request comes in. That's you, trying to buy something. Before it can hit any server, the load balancer intercepts it. Then it does a super quick health check to find a server that's online and has some room to spare. And finally, it forwards your request to that healthy server. And for you, the user, the whole thing is completely invisible and seamless.
Now this is where it gets really interesting, because not all load balancers are created equal. They have different levels of intelligence. To really get it, let's use an analogy. Think about the difference between a bouncer at a nightclub and a concierge at a 5-star hotel. They both manage access, right? But they do it in very, very different ways. So, the bouncer, that's a layer 4 load balancer, is all about speed and simplicity. It just looks at the basic network info, kind of like the address on an envelope, before sending it on its way. It's super fast and it works for any kind of internet traffic. Now on the other hand, we have the concierge, a layer 7 application gateway. This one is way smarter. It actually opens the envelope and reads the letter inside. It understands the content of what you're asking for, like if you want a video or an image, and it can make much more intelligent decisions because of that. This quote just sums it up perfectly. The bouncer, just make sure you have a valid ticket to get into the building. That's it. But the concierge actually listens to what you want. I'd like to see the image gallery, or I need to watch a video, and then personally directs you to the exact right place. See the difference? And this ability for the concierge to understand what you're asking for, well, that unlocks a whole new level of smart routing and, maybe even more importantly, security. This deeper understanding allows for some amazing features. With URL-based routing, if your browser asks for website.com/videos, the concierge knows, this person needs our special video servers. It can also act as a security guard with the web application firewall, inspecting requests for common hacking attempts and just blocking them at the door. It can even handle all the complex encryption and decryption stuff, which frees up the other servers to do what they do best, just serve you content. So how do you choose which one to use? Well, it really just comes down to what you need. If you're looking for raw, high-speed traffic distribution for pretty much any kind of application, the bouncer's your tool. It's efficient, it gets the job done. But if you have a complex website that needs that intelligent routing and advanced security, then you absolutely need the concierge.
Ultimately, all of this amazing technology serves one critical purpose: handling massive amounts of traffic without ever failing. The real goal is to create a system that can scale up instantly for a huge launch and then, just as easily, scale right back down to save money when things get quiet.
This is really the holy grail of modern web architecture: elasticity. A system that can handle the total quiet of 3 a.m. and the absolute chaos of a Black Friday sale with the same amount of grace. And the load balancers?
They're the conductors of this entire orchestra. All this is done with something called a backend pool, which is really just a group of servers waiting behind the load balancer ready to work. So, during that huge sale, hundreds of new servers can be added to this pool automatically. The load balancer sees them, checks that they're healthy, and boom, it immediately starts sending them traffic. And when the sale's over, those extra servers are removed and you stop paying for them. It's all automated, totally seamless, and incredibly efficient. So what's the end result of all this tech? Reliability that you can actually measure. A really well-designed system using a standard load balancer can achieve a 99.99% availability service level agreement, or SLA. To put that in perspective, that means less than 1 hour of downtime for the entire year. That's the power of getting rid of that single point of failure.
So, the next time a website handles some massive event completely flawlessly, you'll know about the unsung heroes, the load balancers, working tirelessly behind the scenes. It kind of makes you wonder, doesn't it? What other invisible, unbelievably complex systems are out there working perfectly right now just so we can browse and shop and connect with each other online?
Hey everyone, so in this lab we are going to focus on implement network traffic management, and for this lab there are three tasks that we are going to do. Very first task is use a template to provision an infrastructure, where we are going to deploy a template for creating one virtual network, and then one security group and three virtual machines that we are going to do. And then second task is configure an Azure load balancer. So for that we'll set that up front end, and we know that one. Then we will set up that backend, and in between there are help problem and other settings that we are going to do. Mm, that is the second lab. So uh, Azure Load Balancer is in front of two Azure virtual machines that we are going to set that up. So in task 2, we'll implement a Azure Load Balancer. Mm, in task 2, we'll implement an Azure Load Balancer in front of two Azure virtual machine in the virtual network. So load balancer in Azure provide layer 4 connectivity across resources like virtual machines. And for the load balancer, we need front end and also backend. Mm, So backend pool is the different type of services that we are going to provide. Then we'll focus on in our task 3, we'll go through some configuring an Azure application gateway um, in front of two Azure virtual machines. Application gateway provides layer 7 load balancing and web application firewall, SSL termination, and end-to-end encryption to the resource defined in the backend pool. And we'll also see the application gateway, how that routes like for different objects, like for images that will go some specific servers like image related server pool, and for video, a video related server pool. So let's start that one now. So first we need to connect to Azure Portal. Here we have already connected to Azure Portal here. And you need to download all the, let me show you that one again. Let me open that page. If you go to home, you need to download those files which is needed for this lab. So let's go back to network traffic management. So now first here from Azure Portal, search for deploy a custom template. So on the custom deployment template page, select build your own template in the editor. And here, just select the load file. Download it into F drive, all files, labs, and then this is number 6. Then check this. There are two files. One is parameter files and another one is template file. Select template one, click open. When that's done, select save here. Now here option is edit parameters. Select that on edit parameters, and now load that one parameter file, parameter.json. Select open and click on save. Now here select the subscription and select a resource group. Give a password for the admin password. Click next. So now here is that review validation in progress. Validation done. So click on create. It may take little time because 3 VMs and respective like network, VNet and other required like network security groups all are going to be created here. So I'll come back when those are ready. So deployment is complete now. Let's go to resource group just to make sure that all the resources has been created successfully. So if we check here, let's go to VNet. So it create one VNet, and if we go there, there should be 3 subnets underneath that one, and also 3 VM virtual machines. So you can see that has been created successfully. Now let's go to configure an Azure load balancer. For that one, into search string, search for load balancer. Click this load balancer. Click on create. So we are going to create on standard load balancer here. Select the resource group. Give a load balancer name, and region is same as where I have created all the VM, East US. In my case, SKUs, just considering standard one. Type is public, and tier is regional. The next on frontend IP configuration. So click here that add a frontend IP configuration and give a name for this frontend IP configuration. And IP type is like IP version, IPv4 IP type is IP address, and public IP address. Here you see that select the create new and give a public IP address name. Then SKU is standard, tier is regional, assignment that is disabled here. You can see that one. So availability zone, zone redundant, and routing preferences Microsoft Network. So save that one. If you come back here and get a load balancer is none, select save. So we have done front-end IP configuration. Now we are going to set up backend pool. So select next backend pool. So here click on add a backend pool. Then here give a name for backend pool. After that select the virtual network. Now backend pool configuration is there are two options. One is NIC and IP address. So in our case we are selecting NIC, and here IP configuration. So if I select here add, then you see all those uh, available. In our case, like the VMs we have created, we can see those VMs are here. So for our case, we are going to select VM0 and VM1 under that backend pool. So select those two VM and click on add. Then save. Next, the different rules in place. We'll set that up for not now. We are not setting that up now. So let's just see that one. We can go there, but we'll set that up later on if we need this lab perspective. So click on review and create, and click on when that validation in progress. Let's finish this validation. That is done. Click on create. So deployment is complete. So now click on go to resource. So you can see that load balancer is ready now. So what we are going to do, or what we need to do, to set up a route to determine like how network, like how the incoming traffic is distributed. For that, go under settings, and here you will see that load balancing rules. So select that load balancing rules, select add, give a load balancing rule name, then select the IP version, then front-end IP that we have configured, select that one. Backend pool that we have configured underneath 2 VM, select that one. Then protocol is TCP, port is 80, and backend port is 80. Health prop we did not create yet, so we can just select create a new health prop system. So give a health prop name. Health prop protocol is TCP, port is 80, interval is 5 seconds, and used by not used. Right now click on save. Then it's coming session persistence. Not, we don't want that on. This is mainly for if someone connected and then goes out then come back, it will go to the same server. So like for AWS, that is sticky session. So session persistence none. Idle timeout 4 minutes, that's okay. Enable TCP reset is disabled. Enable plotting IP is disabled. Then on outbound source network address translation SNAT, so that is recommended. Then save. So load balancer rule has been saved. So we have done load balancer rule setup. Now let's see other thing we need to set that up. If we go back, oh here is that one is that I was thinking that I need to go back there, but here I can see that front-end IP configuration that also need to go through and check. So now here you can see that the IP address. So copy that one and open a browser and see that how load balancer is working or not. So we should see two VMs. One is here. It is going to VM0. Let's still VM0. So what we can do, we can just open a in private window and try there. So VM1. So that means load is distributing across VM0 and VM1. So that means our load balancer uh, setup has been completed nicely here. So next we are going to do that configure an Azure application gateway. For that, let's go back to console and search for virtual network. Enter. So select this virtual network. So then under that settings, click on subnets. Then click subnet. Give a subnet name, application gateway that we are giving, and starting address. Subnet address range is not valid. So let me see what the issue is here. That should be 27 now. Yep. So starting address is like 10.60.3.224. Range is 27. Application gateway requires dedicated subnet. That for this separate subnet I'm creating. And other thing, like this should be like 27 or larger size. Click add. Now go back to application gateway. Search for your application gateway. Select that one. Click on create an application gateway. Select the resource group. Get a application gateway, like give an application gateway name. Then select that same region as like we used for to create VMs. Tier is standard V2. Enable auto scaling. We select no. Instance count is 2 for our lab environment. And HTTP2, we are going to disable that one. Virtual network, select the network that we have created. So this is the subnet that we have created under that VNet. So next, front end. So here is public IP address. Select the IP address. So that is load balancer. Let's select a new IP address. So give a public IP address name and availability zone is zone redundant. Then click next, backend. click add a backend pool, give a backend pool name, then here add backend pool without target, select no, then backend target type is select virtual machine in our case and select unique, so that is one. Another virtual machine is 2. Click add. Now next configuration, here we can see that add a backend pool. So this time we'll select image and add a backend pool without target, no, and for image we are going to select virtual machine, and that will be NIC1. Click add another backend pool. So this time that is for video, this specific to video. So we select, we give a name, backend pool without target is no, and that will be a virtual machine, that will be second one. So this one, click add. So first that application gateway has got both VMs, then in our case we just decided, okay, if image, then it will go to NIC1 VM, and second VM it is for video that we have done. So now here there is a routing rule, so select that, add a routing rule and give a rule name, give a priority number, then listener to listen the specific port and IP address, so select give a listener name, select the front-end IP, which is public IP before, protocol HTTP, port is 80, listener type is basic, then click add. Oh, I missed that backend target. So here backend target, so give a backend target, select here, that is AWPGWBE, and then so application gateway backend. So then here it's coming backend settings. So select that, add new. So give a backend settings name. Backend protocol is HTTP, all are considering default, just select add. So we have done backend settings. Now this is path-based routing. Where we are passing two different VMs, so one for image and another for video. But in actual environment, that can be many VMs that you can set that up based on your route. So here under the path-based routing, you see that add multiple targets to create a path-based routing. So select that one. Then here it's coming like the path. So let's select for first one is image. For image, give a target name. Select the backend settings. And backend target is image. For this one is image one. So image backend. I've selected that one. Add. Then you can to select another one, which is for video. video backend, add, then click on add. For tags, we are not changing anything. So next we can just create a review and create. Validation pass, so click on create now. So it may take little time to create that application gateway. I'll be back when that has been that will be completed. So deployment is complete. Let's go to resource group. And here, let's see the application gateway. Select that one. Now we can see the front-end IP address here. So let's open here. Type this. Get the front-end IP. So for the image, it's going to VM1. And if we go for the video, it's going to VM2. That's the way we set that up. If that is image, it will go to VM1, and if that is in video, then it will go to VM2. So we have successfully completed our lab. If you have any questions, please put into comment section. Otherwise, see you in lab, and please subscribe to my channel. Thank you.